I did the stats questions first, and I'm pretty sure they were 13 and 14, so we've only got 2 left by my reckoning. That horrible number was right, by the way, on question 10, minus 8,685 over 16, I think it was. I should have more confidence. All right, curve C1 has the equation, this. Curve C2 has the equation, this. Verify that when x equals 1, the curves intersect. So if they intersect, then both x and y are equal at that point of intersection. I'm going to write that down. I know some of us have a very deep resistance, I guess is the word, to writing words in maths. This pen's lagging. It doesn't take you half as long as it's taking me with this drawing tablet to write on your exam script. At the point of intersection, x and y ordinates are equal on both lines. So, curve C1, y equals, let's sub in x equals 1 and see what we get. Write an x there, I meant to write 1, because that's my substitution, plus 6 lots of 1 squared minus 1 cubed gives me 8 minus 10 plus 6 minus 1, which equals minus 2 plus 6 is 4 minus 1 is 3. Y equals 3 when x is 1. I'm going to put that here as well. I like writing words. When x equals 1. In fact, let's put a nice big bracket around all of this. This is all what happens when x equals 1. Let's see what happens on curve 2. Y equals x squared minus 12 lots of 1 plus 14. One minus 12 plus 14, y equals 3. Yeah. So there we go. Don't need to write anything else. I did my writing at the beginning. At the point of intersection, x and y ordinates are equal on both lines. We can see when x is 1, both lines return a y ordinate of 3. Therefore, we've got a point of intersection. Done. Okay. Curves also intersect when x equals k. Use algebra to find the exact value of k. So we've got another point of intersection, which means if we set both of these lines equal to each other, because at the point of intersection, as we know, those y ordinates are the same. So both of these equations are in terms of y equals this, but at that point of intersection it also equals that. So those two things are equal. Oh, let's gather some things over here. So take away the x squared, that will give us 5x squared. Add on 12x, that'll give us plus 2x. I'm wishing I'd done this the other way around because I want my x cubed to be positive. I always like to have the biggest power of x as the positive, as a positive term. The positive term, there might be more. So I'm going to take everything onto the other side instead. That's going to give me a positive x cubed. Take 6x squared away from 1x squared, gives me minus 5x squared. My x terms, I'm going to be adding 10x on to minus 12x, giving me minus 2x. And my constant term, I'm going to be taking 8 away from 14, giving me 6. And I've got nothing left on the other side, 0. So I get a cubic equation. I already know there's a point of intersection when x equals 1, which means x equals 1 is a root of this equation. Factor theorem. If x equals 1 is a root, x minus 1 is a factor. So once we know that x minus 1 is a factor, my preferred way is to get the long division out. There are other ways, but we didn't do them because this is the way I want you to do it. Love long division. It's so cool. X cubed divided by x is x squared. Multiply back through, we're going to get an x cubed, and we're going to get a minus x squared. So we subtract to find our remainder. Minus 5 minus minus 1 is really minus 5 plus 1. It's minus 4x squared. Bring the next term down. Divide by x gives us minus 4x. Multiply back through, and of course we get the minus 4x squared. We also get plus 4x. Minus 4x times minus 1 gives us positive 4x. I'm going to take away, minus 2 take away 4 is minus 6x plus 6. Divide by x gives us minus 6. Multiply back through, minus 6x plus 6. There is no remainder. That's very good to know, which means that we can factorize this cubic as x minus 1, x squared minus 4x minus 6. So we need to solve this quadratic here now. I think this said, yeah, it's one of these, again, solutions relying on calculator technology are not acceptable. So, again, it's probably more to do with this because your calculator will solve cubics for you. But just in case it also doesn't like you solving the quadratic this way, let's solve the quadratic with a formula. Minus b plus or minus root b squared minus 4ac over 2a. I don't use this very often. So we'll give it an airing. Minus b is 4, plus or minus square root of the discriminant b squared is 16. 4 times 1 times minus 6 is minus 24. So 16 minus minus 24 is 40 over 2a 2. So x is 2 plus or minus root 40 over 2. This third's going to simplify, isn't it? 40 is 4 times 10. Let's do this separately over here. So it's root 4 root 10. Looks like 16. 2 root 10. And 2 root 10 over 2 is just root 10. So x is 2 plus or minus root 10. But there was some caveat in the question, I remember. Let's go back and have a look. Given that k is less than 0. Okay, so only one of these is less than 0. 2 plus root 10 is not 0. So reject. 2 plus root 10. X equals 2 minus root 10. Again, just explain what you're doing with a few words. We're not writing essays, but those people who are so averse to just writing the odd word here and there, you're really doing yourself a disservice, because it's so much nicer to mark an answer that is really clear as to what is going on. And I mean, obviously the fact that your paper is nicer to mark is not going to make a difference to the mark that you get. But please cut me a break. Alright, so we've done that one. There's only one left. I guess we'll do that next. Here goes.